Good morning, students. Today we are going to start the new topic, that is longitudinal and torsional vibrations. Basically, the vibration is nothing but when the vibrations will be created. When an elastic body is such as a spring, either maybe a beam and a shaft, which is displaced from a equilibrium position by an applying of external force. So if you consider a ball or a spring which is to be placed on the over the spring, whenever an external applied force is on the spring, there is a deviation in the equilibrium position or which is in the exact position. So there is a change in the equilibrium position by applying of external force is known as the vibration, or it is called a vibratory body. So there is a deviation from the equilibrium position or from the original position by applying of external forces, and then it was released. So not only applying the force, when it is released, that will execute a vibratory motion, that is called a vibration. Why? Because the vibration will occur. This is due to the reason that when a body is displaced, the internal forces in the form of elastic or strain energy which are presented in the body. So when we apply the body force on the body, that will results in internal reaction or internal forces in the form of elastic. Due to these elastic, that is by releasing of these forces, which brings the body to its original position. When the body reaches its equilibrium position, the whole of the elastic or strain energy is converted into the kinetic energy. Due to these body continuous move up and down, that is which are when we apply the force on a spring which is in the downward direction and we release the force, then the spring will be move up and down. So that will creates the kinetic energy. The whole of kinetic energy is again converted into strain energy, due to the which the body again returns to its equilibrium position. So it is not be stable, or it is not be continued until for a longer period. So it is not possible. By the how much of energy or how much of force you have applied in the spring, that will be resulting for a limited period only. Okay, limited period only the spring will move up and down. After a certain period of time, the body or the spring will comes to the equilibrium position. Since whenever we applied the force, that will converted or internally an elastic energy will be developed, that is strain energy, that is converted to kinetic energy. So that will jump up and down. After certain period reaching, the kinetic energy again comes to the strain energy, or that is coming to the equilibrium condition. In this way the vibratory body is repeated indefinitely. So like that the body is moving up and down. Then what are the terminologies we need to remember for the vibratory body? Here we are seeing commonly used in the connection with the vibratory motions. One is period of vibration. That means time period. How much of time we have spent, or how much of period of time the motion is repeated itself. That is, it is the time interval after which the motion is repeated itself. The period of vibration is usually expressed in seconds. And then next is cycle. It is the motion completed during one time period. So within the time period, how much of motions was completed? So it is the motion completed during one time period. Next, frequency. Mainly the frequency is expressed in hertz, which is of SI units. What is the frequency means? The number of cycles in 1 second. In a second, how many cycles were described? The number of cycles described in 1 second. In SI units, the unit name is hertz, which is equal to 1 cycle per second. Next, what are the types of vibratory motion? So here we are having three vibratory motions. One is free vibration, forced vibration, damped vibration. Free, in the name itself, we are having that no external force is acting on the body. So we call it as another name also there, that is natural vibration. Free means naturally, no external effort is required. After giving it an initial displacement, then the body is said to be under free or natural vibration. Then the corresponding frequency known as natural frequency. Next, forced vibration. When a body in the forcefully, that means by an applying of or by influence of external force. When the body vibrates under the influence of external force, then the body is said to be under forced vibration. And the external force applied to the body is a periodic disturbing forces created by unbalance. This we will call as a uh, another thing is damped vibration. So actually in the forced vibration only there is a resonance will be takes place. Actually the forced vibration or the external force what we are applying in the uh, forced vibrations, it will create a resonance. Then next is damped vibration. When there is a reduction in amplitude over every cycle of vibration, that means the amplitude is comes to down for every cycle of vibration, the amplitude is coming down, that is called damped vibration. But why means this is due to the fact that a certain amount of energy is possessed by the vibrating system and it is always dissipated in overcoming frictional resistance to the motion. So why means certain amount of energy is by the body which is vibrating, it will takes some amount of energy which also dissipated in overcoming the frictional resistance. Okay, and then what are the types of free vibrations? So free vibration, as you know, free means without applying of any external effort. Here there are three types of free vibrations. One is longitudinal, transverse and torsional vibrations. Basically, in any vibratory motion is coming to under these things only. Okay, then what are the types means? Longitudinal, transverse, and torsional. Let us consider a diagram. If you see this diagram, consider a weightless constraint. Let us consider a shaft whose one end is fixed. If you see the first diagram, firstly, the upper end of the shaft is fixed and the other end is carrying a weight, either maybe a disc or whatever a certain weight is attached to the shaft at another end. If you see in the diagram, this system may execute the three types of vibrations. Let B is the mean position, that is which is under normal condition. So if you see in the diagram, the blue color weight or the blue color disc, which is called the position of the mean position, A and C are the extreme positions. So we are calculating that without applying of any force. The disc or weight is in the rest position. The normal position of any diagram, in the diagram, the B or the color, the position of B called mean position, that is which is in the rest condition, and C and A are called extreme positions. So in the longitudinal vibration, when the particles of the shaft or disc is moves parallel to the axis of the shaft, then the vibrations are known as longitudinal vibrations. So if you see in the diagram, longitudinal means the axis of the shaft which is in the mean position. After applying of an external force, the axis of deflection or the axis of the shaft during the vibration also parallel to the existing one. So the axis may not be changing the position. That is, in this case, the shaft is elongated and shortened. In this, the shaft is elongated and shortened alternatively, and thus the tensile and compressive stresses are introduced alternatively in the shaft. So in the shaft, if you see, the shaft will move in the up and down. These up and down, we will call it as a tensile stresses and compressive stresses, and the transverse vibrations. When the particles of the shaft, that is the disc, will move approximately perpendicular to the axis of the shaft. Transverse means the axis or the disc is moving perpendicular to the shaft approximately. Then the vibration is known as a transverse vibration. In this case, the shaft is straight and bent alternatively. There is a bending forces are introduced. There is a bending forces are introduced. Next, torsional. In this case, the shaft will move or the disc will move in a circle about the axis of the shaft. If you see the shaft, the third diagram will indicate the by rotating of the disc, the shaft and at the same time the disc is also rotating, then the vibrations are called torsional vibration. So in this case, the twisting, torsional shear stresses are introduced. If the limit of proportionality, that is stress is directly proportional to strain, if not exceeded in all the three types of vibration, then the restoring force in longitudinal, transverse, or the restoring couple in the torsional vibrations which is exerted on the disc by the shaft is directly proportional to the displacement of the disc from the equilibrium, or which is in the mean position. So there is a property called of proportionality. Limit of proportionality is a stress is strain. The relation is not exceeded in all the three cases. The stresses or the restoring forces and the restoring couples is not also exerted by the shaft, is directly proportional to the displacement of the disk. How much of displacement is applied? Then natural frequency. The natural frequency of the free longitudinal vibration. The natural frequency of the free longitudinal vibrations will be described with the methods called equilibrium method. Okay, this is the one of the technique we are applying here. Let us consider a spring. Let us consider a spring which is of negligible mass and in an unstrained position. That means which is in the mean position. So let us take the stiffness S of the constraint. M is the mass of the body suspended from the constraint. Weight W of the body, which is in the Newton. And delta is equals to static deflection of the spring, which is due to the weight by applying of weight. X is the displacement given to the body by the external forces. So if you see in the diagram clearly, in the equilibrium position, the gravitational pull W is equals to mg, which is to be balanced by the spring force. That is W is equals to S delta. S means stiffness of the spring and the deflection. Since the mass is now displaced from the equilibrium position by a distance of x, if you see in the diagram, third diagram, that is C, and it is then released, therefore after the time t, the restoring force is equals to W minus S into delta plus X equal to W minus S delta minus Sx. SW, S delta, we write it as the spring force. So SW, write it as S del W is equals to S delta, or S delta is equals to W. Okay, the both will be cancelled. The finally restoring force Sx, and the acceleration force is of mass into acceleration is equals to m into acceleration d square x by dt square, taking the downward force as positive. And then by equating these, w is equals to s delta and m into d square x by dt square, by equating these we get a formula called omega is equals to square root of s by m. Then omega is equals to s by m, that is called, we can say that omega as angular velocity, and then time period is equals to tp, that is time period is 2 pi by omega, that is equals to 2 pi into root of m by s. So this is a very important formula for omega as root of s by m, and time period as Tp is equals to 2 pi into root of m by s, that is reciprocal. Okay. Then whatever the natural frequency, the reciprocal of frequency is the reciprocal of time period. So that is equals to 1 by Tp, that is equals to 1 by 2 pi into square root of s by m, or the s by m we will write it as s is equals to w by delta. S is equals to, we know W is equals to S delta. So in place of S, we write it as W by delta. Then W means mg by m delta. So m cancel means finally we got a relation as g by delta. By taking the value of, we know the g as 9.81, so by substituting that in the equation, the frequency, natural frequency Fn is equals to 1 by 2 pi into square root of 9.81 by delta, that is equals to, when we come out of from the root of and at the same time 1 by 2 pi, we calculated that 0.4985 by square root of delta hertz. The frequency notation is hertz. And one more important method is, actually it is a energy method. So energy means we are calculating the kinetic energy and potential energy. So when we consider in the free vibrations, no energy is transformed to the system or from the system. So the summation of the kinetic energy and potential energy, which must be a constant, that is equal to 0. So that's why the method is, which we obtained here, the formula, both are same in the content. So there also we are finding the frequency formula as 0.4985 by square root of 8. So coming to in all these three cases are applied for finding the free frequency of free longitudinal vibrations. In all the cases also we are getting the same relation only. So now we are dealing with the Rayleigh's method. In this method, the maximum kinetic energy at the mean position is equal to the maximum potential energy. Since the Ke is equal to Pe. When means in the extreme position only. So then that will executes by assumptioning this, that is Ke is equals to Pe. There is a vibration called simple harmonic motion will be applied. So simple harmonic motion, the equation is x is equals to x into sine of omega t. X is the displacement of the body from the mean position after a time period t seconds, and capital X is the maximum displacement from the mean position to the extreme position. So by differentiating the equation 1, which is x is equals to x into sine of omega t, dx by dt is equals to omega into x into sine of, by commonly take it out of the x, we are having differentiation of sine, we call it as a cos. So uh, omega x into cos of omega t. Since we need that at the mean position, that means rest position, the t is equals to 0. So the maximum velocity at the mean position as v is equals to, v means the velocity. The maximum velocity is nothing but the differentiation of the displacement. So what we are getting the displacement here, dx by dt. Okay, so when we consider the displacement dx by dt, we will call it as a v, velocity. So when this will be maximum, when this will be maximum, the cos will be 0. Okay, or the cos is to be 0. Sin 91, cos 0 is 1. So v is equals to, the cos value is to be 0. The omega into x into, by substituting at the mean position, the t is 0. So cos omega t into x. So cos omega t, cos omega into 0, cos 0 is 1. So the formula v is equals to omega x. Then maximum kinetic energy at mean position. The maximum kinetic energy at the mean position, what is the formula? Half mv square. So half m v square means omega square into x square. And at the same time potential energy. Potential energy at the extreme position also the same. That is equals to half into sx square. So by equating, since we have in the initial stage itself, we say that maximum k is equals to maximum p. So by equating these two, half m omega square x square is equals to half s x square. Both x square cancelled, half cancel, m omega square is equals to s. Then omega square is equals to s by m. There by omega call it as a square root of s by m. Then time period Tp is equals to 2 pi by omega. So 2 pi into square root of s by m. Okay. And the reciprocal, sorry, m by s by natural frequency is reciprocal of time period. So omega by 2 pi is equals to 1 by 2 pi into square root of s by m. In all these expressions, in all these expressions, we discussed about the omega. These omega known as natural circular frequency. Natural circular frequency. That we will call it them in the problem mostly with the notation called omega n. So for simply omega n means, omega means frequency, natural circular frequency. Natural means omega n.